Okay, I've decided to kind of back up here and redo the last example we just saw. And I want to show you what's going to happen. You know how I was telling you guys, you want to make sure you pull all the numbers to one side. So I want to show you what's going to happen if you don't do that. So we had 10x squared plus x equals 2. And if you went ahead and tried to break this down and solve for x, like in this case, let's looking at this side, you could technically pull out an x and you'd be left over with this on the parentheses. And if you want to verify that this down here equals this one up here, you can go ahead and pass this x back through and multiply it through. But it does work out. So now what we're going to do is, this is equal to 2, sorry, let's just drop it down. Kind of like the zero factory property. When we had over here, previously we had 0 there. What we did is we took each part and broke it up and set it equal to 0. So in this case, we've got 2 on the right-hand side. So we're going to set each one of these, the parentheses and the x, equal to 2, and then solve for x. And see if we get the same answer. So obviously over here, is already done, x equals 2. Going to the right-hand side, you're going to subtract 1. So you have 10x equals 1. Now you're going to divide by 10, so we're going to solve for x and get 1/10. So going this route, your solution set is something of this nature, which is definitely not what we got before. That was -1/2 and 2/5, I believe. Yep. So as you can see here, this is the incorrect method, where you did not bring everything over to the left-hand side where the equation is equal to 0. So I just wanted to, I figured it'd be good for you guys to actually see it being done incorrectly. Okay, now the previous example, when we did it correctly, we had a -1/2 and 2/5 for our answer. And so we have two answers there, right? We have -1/2, that would work out, and we also had 2/5 that worked out. And this is because your equation was quadratic. And again, what's quadratic mean? Well, that means that your variable x, it was squared. So this right here is a whole, that should be yelling at you that your equation is quadratic if you see that in there. And that should also tell you it's degree 2, so you could have a combo of two answers, or maybe even the same answer but reproduced twice, as one is negative, one is positive, which of course is two answers. So let's do another example. Okay, so we already see that part of it's already done for us, which is the pulling everything to the left-hand side, so it's equal to 0. So let's go ahead and just go into our parentheses and figure out what we're going to put on in each parenthesis. Well, again, look here. You've got x squared. There's no constant out in front of it. Well, there technically is, which is a 1, but anything times 1 is itself, so you can ignore this here. But so you got x squared. So x times x gives you x squared. Now, just like before, we look at the very far right of it on the last problem, and that was your constant. And in this case, this is also your constant, which is -16. So now we need to find two numbers that multiply together to get -16. And obviously 4 times 4 is 16. We want it to be negative, so that should tell you automatically that you're going to have one is negative and one is positive. Again, if you want, you can double check yourself and go ahead and refoil these two parentheses and make sure it equals x squared minus 16. I can assure you it does. So again, zero factor property. We're going to use that now, and that's where we take this set of parentheses and equal it to 0 and solve for x, and then do it the same on the other side, or the other parentheses. Get the tongue tied here. So we're going to subtract 4 from both sides, so we got x equals -4. That, we're going to add 4 to both sides here, so x equals 4. So your solution set in this case is going to be -4 and 4. So again, you got two answers because it's quadratic, and in this case they're the same answer but different signs, negative and positive. Okay, let's move on to the next topic, which is the square root property. And basically what this says is, let's say you have x squared equals b. Well, if that was your whole problem and you wanted to solve for x, you would say what? Well, you're gonna take the square root of both sides. Again, that was x squared. And this square root and the exponent of 2 are going to cancel out, leaving you with x. And the square root of b, the thing that a lot of people forget here, which I didn't write it there, but I'm going to bring it down here to explain it. So whenever you take the square root of the opposite side, you have to remember that you have a plus and a minus square root of whatever it is. In this case it's b. And that's there simply because of the square root. So don't forget that. Let's see. Another example. Trying to think of one here. Let's see. X squared equals 29. Again, what you're going to do is you're going to take the square root of both sides. The square root, the radical, and the exponent of 2 are going to cancel out, leaving you with x. And then you'll have the plus or the minus square root 29. So that's your final answer there. One more example real quick. We got, let's see, let's get one that maybe works out a little nicer. We got x squared. Let's pull some complex numbers into it since you guys just did that. So we got negative 144. So going back to section 1.3, the first thing you guys should do here is pull out the VI, or which is the root negative 1. I'm sure you guys remember doing this from last time. And since we took the square root of both sides, this and that will cancel out, leaving you with x on the left-hand side. And we know the square root of negative 1 is I. So you can factor that in, or sub that in. And you also know the square root of 144. You guys should know that 12 times 12 is 144, or maybe just punch it in your calculator if you're not for sure and double check. Oops, and I also forgot the plus and the minus here. Don't forget that, like I just did. But so what that'll give you is, because the square root of 144 is 12, so your final answer will be this. And of course you can write it, either way here. There's this one and this one. They're the same thing. I just like to write it that way because it looks cleaner. So it's up to you on how you finish it off. Okay, one more example, a little bit trickier, I guess. X minus 8, this whole thing is squared, equals 24. So again, we've got this square here, and we want to get rid of it. So to get rid of the square, you take the square root of both sides, and that'll always get rid of that. So in this case, that and the square will go away, your radical and your square. So you're left with x minus 8 is equal to plus or minus square root of 24. The tricky part here, or the critical thinking, I guess, should kick in and say the square root of 24. That should kind of trigger something in your mind that you can break that down. And if you don't remember how, here's a quick reminder. Figure out two numbers that go into, excuse me, two numbers that multiply together go into 24 that you could potentially reduce. So what are two numbers? Let's say 4 and 6. Get your square root. Because the square root of 4 is 2. 2 times 2 is 4, so the square root of 4 is 2. So here you actually have this. And this can be subbed in place of the square root of 24. So let's sub that in. Okay, and again we're solving for x because that's the only variable. So go ahead and add 8 to both sides. So we got 8 plus or minus this. So because of these plus or minus right here, you actually have two answers. You got 8 plus 2 root 6, and you have a minus 2 root 6. So if you were to report to me only this one, you know, you'd get maybe a point marked off or something. Same thing, if you only reported this one, you might get something marked off. So again, keep in mind you've got two answers sitting there.